Okie dokie. So um, I wanted to show you how to do a hypothesis test for R. Again, the correlation coefficient. The homework is not as actually involved as what we would have done in class, but I feel like I should still explain it so you know what I'm talking about. It's actually pretty easy. And again, I'll show you how to do it typically, and then the way the homework asks it, how to make sense of that. Oh, Target has a sale on women's dresses. Okay, so again, just to review, the value of R ranges from -1 to +1. And if the value of R is close to what, it can indicate a strong negative correlation. So again, if R is close to -1, that's showing a strong negative correlation. If R is close to +1, it can indicate a strong positive correlation. And if the R value is close to 0, it can indicate a weak or non-existent correlation. So when we set up our hypothesis, there's two possibilities. That the value of R is high enough, there enough, to conclude that there is a strong linear relationship, either positive or negative, or that the value of R is due to chance. And some, it could be one of those rare examples that we had about like autism and organic food, right? That isn't, typical, not a typical relationship. Oh, let me pause it. Okay, so my husband came in and interrupted me, and I kind of forgot where I left off. So, when we test the hypothesis for R, it's set up that we have one of two choices. Okay, our default or our null hypothesis is that R equals 0. So if it equals 0, again, that means that there's no correlation. Okay? So it's saying here that the null hypothesis means there's no correlation between the variables in the population because everything is taken from samples. And my cat is rubbing himself on the camera. So now the alternative is only this. There's no other option. This is what it is. It's saying that that R is not equal to 0, whether it's positive or negative, right? So the alternative hypothesis means that there's a significant correlation between the two variables. And just like we used population's symbol for mean, like that mu, sometimes you're going to see this. Rather than using R, they use the population symbol for R, which is another Greek letter called rho. But I tend to use R because, why not? Okay. So these are the set statements. They don't change. R equals 0 for the null, and R does not equal 0 for the alternate. And the good thing is we don't have any math other than looking at what number is bigger. So we don't need this. And if this were in class, we would be using a new table, which is called table I. All right. And looks like this. And it is under your files in modules. So in table I, we get our critical value. And since it'll be a two-tailed test because of the not equals to, then we'll have a plus minus. Okay. And the premise is that if our value is greater than the critical value, then we can reject the null hypothesis. So let's do one. All right, here it says Data was collected on 7 students for a study on the number of absences in their final grade. R value is computed to be negative 0.944 at alpha at 0.05. 0.05 can be concluded that there's a strong negative correlation between the number of absences and the final grade. So again, hypothesis set. I'm going to say that R equals 0 for the null, that there is no correlation. And the alternate is that it doesn't equal 0. So going back to the absolute value of, math, the absolute value of a negative number is a positive. The absolute value of a positive number is still a positive. Okay, so that's our R value. Now we have to look up our critical value in the new table. And in this case, degrees of freedom is going to be n minus 2. So if we had 7 students, our n is 7, so our degrees of freedom will be 5. So you can see that a little bit closer. Okay. There, that's better. Okay, so we have 2 columns. We have alpha at 0.05 and alpha at 0.01. That's it, no other choices. It tells us here that n, our degrees of freedom is n minus 2 for this column. And here it tells us exactly what to do. It says reject the null if the absolute value of R is greater than the given value in the table. So our degrees of freedom in this case was 5. We went to 0.05, and we have this critical value of 0.754. All right. Okay. Because it's a two-tail, we typically have the plus minus. So now we decide, is R greater than or less than 0.754? Hopefully you said greater than. All right, so if your R is greater than your critical value, reject the null hypothesis. There is sufficient evidence to support a strong negative correlation. All right. So using this table is what we would have done in class, but the homework has a little bit different. So we're going to look at that real quick. One second here. I should have had this up. All right. So it doesn't ask you to state a hypothesis or anything like that, but it gives you basically a table, like table I, and it's asking us if R is significant or not. So, would you reject or not reject? So it tells us the R value right here, and it tells us how many whatever's in the sample, the n value, and whether or not it's significant depends on, again, determining the relationship between R and the critical value. So here you see degrees of freedom, DF, and then you see CB for critical value, plus and minus. So the degrees of freedom is n minus 2. So if we have here 29, we're going to do 29 minus 2, so we get 27. So we're looking right here. So the critical value is 0.367, plus or minus. And it's asking us to whether R is significant or not. So to answer it this way is kind of the same. So if we think about 0.463, then is 0.463 bigger than 0.367? Yes, it is. So it's bigger than this. It's not between negative 3.67 and positive 3.67. It's outside of that, so it's bigger than this critical value. So that means that R is significant. So in this case, we would choose the option that it is significant because it's not between the positive and negative. So that's what we would select. And it tells us right there. So same kind of setup. If R is outside of your range of your positive and negative critical value, then you would say that R is significant. And let's do this. Okay, so here we have n equals 32. So 32 minus 2 gets us 30, which is right there. And a critical, or excuse me, an R value of 0.659. So again, is 0.659 outside of the range of plus minus 0.349? Or in other words, is 0.659 bigger than 0.349? Yeah, it is. So since it's bigger, that means it's outside of that range and R is significant. So it's not between those critical values. And am I gonna get one that's not? Okay, so here we have n equals 23. And so our degrees of freedom would be 23 minus 2, so that gets us to 21. And here we have an R value of negative 0.256. So just thinking about, positive value of it is 0.256 bigger than 0.413. No. So what that means is that if we think about the positive and negative critical values, R would fall between that. So it's not bigger, so it's not significant. So we would choose this one. And it explains it right there. So whatever that R value was, 0.25, whatever, it's going to fall between this range. So it's not bigger than it, so it's not significant. All right, so hopefully that makes sense. And that might be the last video you're going to see. So you're free. Yay!